we are going to find the antiderivative of 4x cubed plus 2x squared plus 5x plus 6. Now, to find this, the antiderivative is the opposite of the derivative. So we have to do the opposite of what we did to find the derivative in the first place, to find the antiderivative. So with this, we would have used the power rule to find the derivative. So say you have 2x squared. If you use the power rule to find the derivative of this, you would do the coefficient times the exponent, 2 times 2, so we would get 4, then we would subtract 1 from the exponent and just get 4x. And this would be our derivative of 2x squared. So if we're going to find the antiderivative, what we're going to do is we're going to take 4x, we're going to keep our coefficient the same, but we're going to add 1 to our exponent, so that would be 2. And now we're going to divide by our new exponent, and we get 2x squared, which is our antiderivative. Alright, so now we're going to go to this problem and work that out. So we have 4x cubed. Alright, we're going to find the antiderivative of that. We're going to keep our coefficient the same. We're going to add 1 to our exponent and divide by our new exponent. The 4's cancel out and we get x to the 4th. Alright, now if we use 2x squared, we're going to keep our coefficient the same, add 1 to our exponent and divide by our exponent. And we get 2/3 x cubed. Now if we're using 5x, keep our coefficient the same, add 1 to our exponent and divide by our new exponent. We get 5/2 x squared. And now finally with 6, we are going to add an x, which is like adding an exponent, divide by our new exponent, which is just 1, we would get 6x. So then we add all of that together, and we get x to the 4th plus 2/3 x cubed plus 5/2 x squared plus 6x. Now, since we're just finding the general antiderivative, there could be many different functions with the same slope, the same derivative. So we are going to add a plus c on the end, just because it could mean this is just the general antiderivative for that whole family of functions. And this is our answer.